Hello and welcome. I am Dr. K. Meena, Associate Professor and Head Department of Mathematics, Arulmigu Palaniyandavar Arts College for Women, Palani. In this video, I am going to explain some elementary transformation, the definition of linear transformation and bilinear transformation. First, transformation. A function f from C to C, that is the transformation from one complex plane to another complex plane. Take z equal to x plus iy. Z is the domain of the function, that the image is f of z. So the take f of z equal to w, the function f from z to w. Z is xy plane, w is uv plane, that is w equal to u plus iv. This complex function w equal to f of z is called complex valued function of a complex variable. So this complex function w equal to f of z can be regarded as a mapping or transformation of the points in the z plane to points in the w plane. Points in the z plane means x plus iy, that is x comma y. The point is x comma y. Point in the w plane means u comma v. W equal to u plus v means u comma, that is z is xy plane, w is uv plane. Using this complex valued function w equal to f of z to derive the following transformation. First, see the elementary transformation. Elementary transformations are translation, rotation, magnification and inversion. First one, translation. Translation means w equal to z plus b, where z is complex number and b is a complex constant. If z equal to x plus iy, w equal to u plus iv and b equal to b1 plus b2, put the value, then we get w equal to z plus b, that must be equal to x plus iy plus b1 plus ib2. What is that value? X plus b1 plus I into y plus b2. What is the real part of w? X plus b1. The imaginary part of w is y plus b2. So under this transformation, w equal to z plus b, the coordinate is in z plane is xy, then w plane the coordinate is x plus b1 comma y plus b2. Using the above result, take b equal to 2 plus i. What is the value of w? X plus 2 plus i into y plus 1. From the figure, under this transformation w equal to z plus b, let's see how the region ABCD in z plane is changed in the w plane. Take a is 0, 0. The image point a dash is 0 plus, that is x plus 2 comma y plus 1 means 0 plus 2 comma 0 plus 1. What is the value of a dash? 0 plus 2 comma 0 plus 1 means 2 comma 1. Next, b is 1 comma 0. The image b dash is 1 plus 2 comma 0 plus 1. B dash is 3 comma 1. C is 1 comma 2. Then the image c dash is 1 plus 2 comma 2 plus 1 means 3 comma 3. So d is 0 comma 2. The image d dash is 0 plus 2 comma 2 plus 1, that is 2 comma 3. Finally, we get the region ABCD in the z plane mapped into the region a dash, b dash, c dash in w plane. But here these two regions a, b, c, d and a dash, b dash, c dash, d dash, these two regions have same shape, size and orientation. In particular, the image of a straight line is straight line and the image of circle with center a and radius r is a circle with center a plus b and radius r. In w plane, the region a dash, b dash, c dash, d dash is displaced with respect to b. But the regions sizes are same, shapes are same, orientation is same. Okay, finally we get under this transformation, the image of straight line is straight line and the image of circle is circle. Next, rotation. The rotation means w equal to az, where modulus of a equal to 1. Take a equal to I. Modulus of I is 1, therefore modulus of a equal to 1. W equal to az means I into x plus iy. What is that value? Ix minus I square. That is I square value is minus 1. Therefore W is Ix minus y. The real part is minus y, imaginary part is x. In z is in the point xy, the image point w is minus y comma x. So xy is changed to minus y comma x in w plane. Therefore, the a is 0, 0. What is the value? The rotate under the transformation w equal to a is 0, 0. What is the image A dash? Also 0, 0. B is 1, 0. The image point B dash is 0, 1. C is 1, 2. The image C dash is minus 2, 1. And D is 0, 2. The image D dash is minus 2, 0. Okay. So the image of the region ABCD in the Z plane is mapped into the region A dash, B dash, C dash, D dash in the W plane. Let Z equal to R e power I theta. So W is AZ. Take A equal to e power I alpha. E power I alpha means cos alpha plus I sin alpha. That the modulus value is also 1. Square root of cos square alpha plus sin square alpha is 1. Therefore, the modulus value of A is 1. Therefore, W equal to AZ means A value e power I alpha, Z value R into e power I theta. After the simplification, the W value is R into e power I of alpha plus theta. So, we get the coordinates r comma theta in Z plane is mapped into the coordinates r comma theta plus alpha in the W plane. Under this transformation, the image is rotation through the alpha angle or argument of A about the origin. Suppose we will take A equal to I. The polar coordinates are cos pi by 2 plus I sin pi by 2. What is the argument of A? Pi by 2. Pi by 2. Okay. So, under this transformation, the coordinates r comma theta in the Z plane is mapped into the r comma theta plus alpha in the W plane. The any straight line, images of straight lines are mapped into a straight line, and the circles are mapped into circles. Okay. Next, magnification. Magnification means W equal to BZ, where B greater than 0 and B is real. Take B equal to 1.5. So, W equal to 1.5 into x plus iy. What is that value? 1.5x plus I into 1.5y. So, Z is xy. What is W? 1.5x, 1.5 into y. So, A is 0, 0. Image A dash is 0, 0. B is 1, 0. B dash is 1.5, 0. But that is 1.5 into 1, 1.5 into 0. Therefore, B dash is 1.5, 0. C is 1, 2. What is C dash? 1.5 into 1, 1.5 into 2. That is 1.5, 3. D is 0, 2. What is the image D dash? 1.5 into 0, 1.5 into 2. That is 0, 3. Okay. So, in the W plane, the value, the same size are changed. The size is expand with respect to the value of B. Only the size is expanded. Next, inversion. Inversion means W equal to 1 by Z. Let Z equal to R e power I theta. What is 1 by Z? 1 by R into e power minus I theta. So, in the polar coordinates, the value R comma theta in Z plane in the image point of the coordinate in W plane is 1 by R comma minus theta. So, the point A, we take A 0, 0. The image A dash is 1 by 0 plus I 0. What is that? Infinity. So, A dash is infinity. So, B is 1, 0. The image B dash is 1 by 1 plus I 0. What is that? 1. So, 1 means 1 plus I 0. That is a 1, 0. The B is 1, 0. The image B dash is 1, 0. C is 1, 2. What is the C dash? W is 1 by Z. 1 by Z means 1 by 1 plus 2i. What is the value? 1 by 1 plus 2i. Multiply and divide the conjugate of 1 plus 2i. So, 1 minus 2i by 1 minus 2i. So, after the simplification, the W value is 1 by 5 minus 2 by 5 into I. So, real part is 1 by 5, imaginary part is minus 2 by 5. So, in Z plane xy, the W plane is changed, the inverse value. So, C is 1, 2. The C dash is 1 by 5, minus 2 by 5. So, D is 0, 2. What is the image? D dash is 0, 1 by 2. Okay. So, under this transformation, the W value is changed in the value of Z x plus iy. The W value is changed. Okay. And next, the value of the rotation value. And take W equal to U plus IV. Let's see how the region ABCD, the changes in the figure. The above three conditions, translation, rotation, magnification, the images straight line is straight line, the images of circle is circle. But this inversion, the images are varied. From the figure, BC is a straight line, but the image under this transformation inversion, the image B dash C dash is curved shape. And CD is a straight line, the image C dash D dash is a curved shape. So let's see the overall image changes under this transformation. W equal to 1 by Z. So W is U plus IV. What is 1 by Z means X plus IV. What is W equal to 1 by Z? 1 by X plus IV. So multiply and divide the conjugate of X plus IY. After the simplification, W equal to X by X square plus Y square minus I into Y by X square plus Y square. So real part U and V. U means X by X square plus Y square. V means minus Y by X square plus Y square. Similarly, Z equal to 1 by W. What is 1 by W? W means U plus IV. So 1 by U plus IV. Multiply and divide the conjugate of U plus IV. So 1 by U plus IV into U minus IV by U minus IV. So numerator is U minus IV. Denominator is U square plus V square. So Z means X plus IV. The real part X, imaginary part is Y. So compare the real and imaginary part. Therefore, X equal to U by U square plus V square and Y equal to minus V by U square plus V square. Now consider the circle equation. A into X square plus Y square plus Bx plus Cy plus D equal to 0, where A, B, C, D are real. Using the equation number 1 in 2, we get, put the value X and Y in equation number 2. So A into X square means U square by U square plus V square the whole square. Plus Y means minus V by U square plus V square. Y squared means minus V the whole square is V square. U square plus V square the whole square. Okay. But plus B into X value U by U square plus V square minus C into V by U square plus V square Y value plus D equal to 0. So after the simplification, A divided by U square plus V square plus B U by U square plus V square minus C B by U square plus V square plus D equal to 0. Multiply through U square plus V square. So we get A plus B, that is BU minus CV plus D into U square plus V square equal to 0. This equation, the image of equation number 2 in the W plane. Put the equation number 3. So A into X square plus Y square plus Bx plus Cy plus D equal to 0. This is a circle equation in Z plane is mapped into UV plane. The circle equation D of U square plus V square plus Bu minus Cv plus A equal to 0. Compare these two circle equations, we get the result. First one, suppose A non-zero, D non-zero, these two equations are circle equation not passing through the origin. So in this case, equation number 2 and 3 represents circle equation not passing through the origin. So we get in Z plane, the circle not passing through the origin are mapped into circle not passing through the origin. And next case, suppose A non-zero, D equal to 0. A non-zero means the equation number 2 in the Z plane, the circle equation is changed. A into X square plus Y square plus Bx plus Cy equal to 0. So constant is cancelled. This is a circle equation. This is passing through the origin because the constant is not there. Okay. So put the value of A non-zero, D equal to 0. D equal to 0 means equation number 3 becomes U square plus V square term is cancelled. So we get Bu minus Cv plus A equal to 0. This is a straight line. This is a straight line with a constant term. This straight line not passing through the origin. So in this case, the Z plane circles passing through the origin is mapped into straight line not passing through the origin in the W plane. Next, A0, D non-zero. A0 means equation number 2, the coefficient of X square plus Y square cancelled and the term is 0, the term is cancelled. So we get Bx plus Cy plus D equal to 0. This is a straight line not passing through the origin. So equation number 3, put D non-zero and A equal to 0. This is a circle equation passing through the origin. So A equal to 0, D non-zero. In Z plane, straight line not passing through the origin is mapped into circle passing through the origin in W plane. Next case, A0, D equal to 0 So these two equations 2 and 3, coefficient of x square plus y square is 0, the coefficient of u square plus v square is also 0. Equation number 2, constant term cancelled. Equation number 3, constant term is also cancelled. We get bx plus cy equal to 0 and bu minus cv equal to 0. These two equations are straight line passing through the origin because constant not contain this equation. Okay, therefore in z plane the straight line passing through the origin is again mapped into straight line passing through this origin. Then we see that under this transformation w equal to 1 by z, the mapping of a circle need not be a circle and the image of straight line need not be a straight line. However, in this transformation w equal to 1 by z, the family of circles and lines are again mapped into the family of circles and lines. Next, find the fixed points of the elementary transformations. What is meaning of elementary transformation? The solutions of the equation z equal to f of z. So take w equal to f of z, find the fixed point of the transformation w equal to f of z means put w equal to z equal to f of z, find the solution of this equation. These are called the fixed points of the transformation. Okay. First find the fixed point of translation. So translation means w equal to z plus b. Put w equal to z. What is that? Z equal to z plus b. So z is both sides cancelled. So z is not defined. Therefore, the magnification solution, that is a fixed point, is infinity. Next, rotation, w equal to az. 1 is equal to 1, that is az. Put w equal to z. What is that? Z equal to az. So z cancel, left side right side z cancelled, so z is not defined. One point is infinity. So we get another point, az minus az equal to 0. The equation is written as z equal to az means z minus az equal to 0. After that simplification, z into 1 minus a equal to 0. So the product is 0, either z 0 or 1 minus a 0. Therefore z equal to 0. We get two values of z. First one 0, another one is infinity. So 0 and infinity are a fixed point of the rotation. Similarly, same value, fixed point of the value of magnification are fixed points. 0 and infinity are fixed points. Next, fixed points of, find the fixed point of inversion. Inversion means w equal to 1 by z. So put w equal to z. What is that? Z equal to 1 by z square equal to 1. So z equal to plus or minus 1. So 1 and minus 1 are the fixed points of this elementary transformation, that is an inversion. So we get the fixed points of translation is, fixed point of translation is infinity, fixed points of magnifications are 0 and infinity, fixed points of rotations are 0 and infinity, fixed points of inversion are 1 and minus 1. Next, linear transformation. A transformation w equal to az plus b, where a and b are constant. This transformation is called a linear transformation. Next, the definition of bilinear transformation. A transformation of the form w equal to t of z equal to az plus b by cz plus d, where a, b, c, d are complex constants and ad minus bc not equal to 0. This transformation is called bilinear transformation, or another name is Mobius transformation. This transformation contains, the numerator is one linear transformation, also denominator contains another one linear transformation. This is a fraction of two linear transformation. This transformation is also known as linear fractional transformation. This is also called linear fractional transformation. So any transformation of the form az plus b by cz plus d with the necessary condition ad minus bc non-zero and abcd are complex constant, this transformation is called a bilinear transformation. Normally the z plane, that is a complex plane, x to xy plane, this x and y not include the infinity value. The complex plane means not include the infinity value. but this transformation t of z, w equal to t of z, that is az plus b by cz plus d. Take a on the numerator outside, so a into z plus b by a, and denominator c into z plus d by c. This put infinity, z equal to infinity. What is t of infinity? A by c. And z equal to minus d by c. What is the t of value? T of minus d by c is infinity. So under this bilinear transformation, the image of infinity is a by c and minus d by c image is infinity. So each and every time include the infinity value, this transformation becomes 1 1 and on 2. This suppose the complex number include the infinity, the C union infinity, that is, this is called a extended complex plane. Therefore the bilinear transformation T becomes 1 1 onto map of extended complex plane onto extended complex plane. The bilinear transformation W equal to AZ plus D by CZ plus D can be expressed as CZW plus dW minus AZ minus B equal to 0. It is a linear in both W and Z, so it is also a